Hello, how you doing, man? I'm Hamish. Let's get started, man. You know what I'm saying? So if you are new right here, okay, make sure you come right here and subscribe. But if you come back, then we'll come back, man. You know, this is like a waste of time, man. It's just easy like this, man. So easy like that, man. Let's get started. So let's see. We have a 2 ohm resistor just connected across the terminal of a battery. So we have a battery. The voltage across the terminal of the battery falls by. Oh, so the moment you connect, the voltage falls by that. So what it tells you? It tells me that if the voltage dropped by 0.3, means that voltage was consumed by battery. You know what I'm saying? So now let's draw a simple diagram. Okay. So let's see. Let's assume this is our battery. Okay. Let's say this is our battery. It's a rough sketch. Okay. This is our battery, and then we connect to external resistor. So there's 2 ways. Either I can connect here. This is my resistor. Or if you don't want to connect like this, another way you can just say, okay, this is my battery here. Okay, this is my battery here. So this is my battery here. And I can say like this. So either or the other, it works. Okay, so what is the ohm? 20 ohms. So 20 ohms. So it is 20 ohms of a resistor. So if I use this diagram and I'll say this is 20 or either of the diagram, okay? So now we have internal resistor. Whenever there's a battery, we have internal resistor. Okay, internal resistor, and this external resistor, big R, and this external resistor, big R. But here we have internal resistor. So what do they say? They say 12 voltage of a battery. Okay, so across the terminal of 12 voltage of a battery, but this voltage across the terminal of the battery falls by. Oh, so now if it was 12 and then falls by 3, means that voltage was consumed by the battery, you know, which is 0.3. So now I'm going to say, let me take 12 minus 0.3. So I'll say, okay. So the voltage I'm going to use is going to be what? 12 voltage minus 0.3 voltage. And this is going to give me 11.7 voltage. So this is the voltage one left. Or the voltage that I'm going to use, okay? Excuse me, the voltage I'm going to use. But the voltage of a battery, me here, voltage of a battery, let me say voltage of a battery. It's going to be what? 0.3 voltage. So voltage of a battery, VB equal to 0.3 what? Voltage. You know what I'm saying? So the other voltage is the voltage of the whole system. I mean the voltage of the whole circuit. So let's say this is voltage of a battery. So let's say voltage other, let's say O, voltage O. Okay, let me say just a voltage. So our voltage that we're going to be left with is going to be 11.3 voltage. So same thing. Like I'm trying to do the same thing here. Voltage equal to 11.3 voltage. Depending whichever diagram you use, it's going to give the same answer. So now, so I have the voltage which is left, you know, and then I know the resistance. Like this is the voltage of outsider, or the circuit is not in the battery. Okay, you know what I'm saying? Sorry, let me just keep silence here a little bit, cause making noise. Silence. Shows my polish. So now for that case now, I'm going to say from Ohm's law, we say from Ohm's law, V equal to IR. Okay. So what is my voltage of the one which is not used by the battery? It's going to be 11.7 voltage. Let's just say 11.7. We're going to put unit letter. Current. You know the current? No, but I have the external resistor, which is, so current, I don't know, by external resistor equal to 12 ohm. So I'm going to divide by 12, I divide by 12. So divide by 12 ohm, divide by 12 ohm. So this is this cancel. So the current that we're going to have is going to be 0.58. It's going to be 0.585 ampere. Oh, so this is going to be the current of, which is going to be circulating around the cycle. Look, so this is circuit here, right? So if this is circuit means this must be positive. The longer one, the positive means the current go all this way and come back here. So the current that's going to be circulated through this cycle, same here, this is going to be positive because this is longer, you know, so whatever is the longest positive. The current, so the current we have is 0.585 ampere, okay? So this current is going to be through the whole cycle. Okay, so now, what do we want? They say determine the internal resistance of this battery, internal resistance of this battery. It's easy, man. How I'm going to get that? Okay, so now I'm going to say, same thing from Ohm's law. V, Ohm's law, V equal to I, but now it's going to be internal resistance. Resistor internal. So voltage now of the battery, because the one resistance of this battery. So the battery, remember, the moment you plug in battery, it drop by this. So what I mean, this is the voltage of a battery. Because why that when you plug in the battery and then reduced by this means it was consumed by the battery. So the potential difference for this case is 0.3 of a battery equal current. Current is going to be the same throughout the cycle, which this one, which is 0.585 times internal resistance of the battery. Okay, so now let's get internal resistance of the battery. So I divide by 0.585 divided by 0.85585. Listen this cancel. So I'll take 0.3 divided by 0.585. And then finally our internal resistance of a battery equal to 0.512 what ohm, because the unit of resistance is ohm. So now it's just easy like this, man. To find the internal resistance with this battery, this internal resistance of this battery. Okay, now let's go to equation number 2. Question number 2 is easy, man. You know, like I say, I feel like I waste my time here because these are easy questions here. Okay. Now we go this question here. Now go to the one. They say that watt heater is connected to 12 voltage line. Oh, how much heat? Oh, so this is the one heat energy. It's easy, man. So from the formula we always say power, always power equal to energy over time. Energy over time. Energy over time. Power, so I can write today, power equal to energy over time. But for this case I'm looking for the heat energy, means I'm looking for this heat energy. So how many energy? I can cross multiplication. So I can just say P equal to energy over time. So I'm looking for energy for this case. So I'll just cross multiplication. So over 1 cross energy times 1 equal to energy. Power times T is power times T. So now, do we have a power? Oh yes, this is the power right here. Okay, so 1000, 1, 2 times time. Yes, we got time. They say it's 2 hours. So these 2 hours, always when you use the time got up in seconds. Okay, so this is going to be 2. Okay, how 2 hours, right? You have to change hour to second. So take my hour, change to minutes. So if it's 2 hours, if I change to minutes, I'm going to multiply by 60 first. 6 first. Oh, we don't want minutes. It has to be in seconds. So second, from minutes to second, you have to multiply again by 60. Multiply again by 60. Okay. So for that case now, if you multiply this, right? If you pre-calculate this, it's going to give you 10, 8. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Okay, so this one here, this is joule, remember. Okay, so we can change to megajoule. Okay, so change to megajoules means you divide by divide all these. I can say this 10, 8, 1, 2, 3, 4, 5 divide by 2, 3, 1, 2, 3. Another 3, 1, 2, 3, and this is megajoule. You know what I'm saying? So now we say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's going to give us 10.8 what? Megajoule. You know what I'm saying? You know? So we're going to have a 10.8 megajoule. Oh, so the energy, or if you want to approximate, so our answer equal to 10.8 megajoule. But if you approximate, it's going to be 11 what? Megajoule. It's just a waste of time. You do this question, and it's easy like that, man. Thanks a lot. You know what I'm saying? Look, man, I believe in learning from how to do things. If it's make sure you subscribe, and you know you can just go and do donation to our Patreon page. I have a Patreon. I have a GoFundMe. You know what I'm saying? I have all the means of donation because to make this project going, you know. any type of donation, the little that you think is too small for you, it could make a lot of change. And thanks a lot for all your time. Subscribe, don't forget, share this video, circulate to a lot of people, because the meaning of this project, this program, is to help as many as we can. Okay, it's not only for one person or two, because you might think it's not helpful for you, but for somebody next out there, it could be very, very helpful. So thanks a lot, man. And any donation that you did to me, it means so much. I appreciate it, man. It means a lot. Go to our Patreon page, go to our GoFundMe, because we need to have a lot of things we need to put them together, like camera, and a lot of equipment, so that we can improve on a lot of angle, a lot of aspects of these projects. Thanks a lot, man. I appreciate and I love you. Peace, man. Bye. This is one of my students of knowledge. She wanted to introduce herself. What's your name? Could you please introduce yourself?
My name is Kamli. I go to South Primary School.
Yeah, I'm trying to Bantu. Trying to Bantu is everywhere, right? So this is my other student. His name, what's your name? Matthew, yeah, he's grade 11, man. So his aim is to score distinction, right? So you promise I want you to score distinction this time. And what's your name? Joshua. How much you promise me to score this time?
Distinction.
Distinction. Yeah, so trying to Bantu is everywhere, man.
Trying to Bantu everywhere. I'm trying to Bantu everywhere.
Everywhere.
Trying to Bantu
Exactly.
everywhere.
Thanks a lot, man. Appreciate it. Thanks so much. If you had to give advice, which advice would you give to the people or to the students?
Trust Amish.
Why would they trust me?
No, because it's really good. They actually has helped a lot. I redid first year for maths. It was my own fault, but also I didn't know a lot of the work. And Amish said lots of hard questions, and it's demotivating sometimes to do the harder stuff. You just want to get done, but it's the hard stuff that makes you realize the easy stuff is easy.
Sing with me and say